roots is that if you understand the square roots, who understands the square roots? So you know what? I think I'm pretty good. Not everybody. Who understands the square roots? If you're playing with the calculator, can you put it down? Well, it's going to show up now if you understand the square roots or not, because the cube roots are really the same thing, same exact process. We're just working with slightly different numbers here. We're working with cubes instead of squares. Can we list the perfect cubes? We did this before during class. How do I make a list of perfect cubes? We know how to make perfect squares. 1, 4, 9, 16, 25. How do I get the perfect cubes? How do we generate them?
1, 4, 9.
Well, those are my perfect squares. And tell me how you're getting it, Jerry. Rather than give me a list, how do you generate them? How do you know what they are? Did you just memorize them? Or how are you getting them? We're cubing, right? So how do I get it? That's squares. 1 times 1 times 1, which is 2 times 2 times 2. Oh, careful, careful. 2 times 2?
8.
4 times 2, 8. So that's 1 to the third power, 2 to the third power. What's the next one? 3 to the third power. 27. 4. Okay, now I know you know them all. But a lot of us, maybe once we get beyond here, it's a little hard. You can actually use the calculator to help you. So I want to show you how you can actually cube something on the calculator. We know how to square it. It's that little F squared button over here. If you're cubing, watch carefully. So we're up to 5 cubed. So you type in a 5, and you want to say I'm raising to a power. Here's how you do it. If you look at your enter button, go all the way up, all the way up, all the way up to divide. Go up 1. Little, like a circumflex. You see the circumflex? Press it. And now say 3. This says I want 5 to the third power. Let's see what it is. 125. So you can generate this list even if you can't memorize it. So that's 5 to the third power. Go ahead, type in your calculator 6 to the third power. What do you get? You're just going to press what you're cubing. And you do 6 to the third power. So what's 6 to the third power? 216. What's 7 to the third power? What's 8 to the third power? What's 9 to the third power? And I hope you know what 10 to the third power is. So there's like the first 10 of them. If you need more, you can always generate more. So we have a different list now. We're not working with perfect squares, we're working with perfect cubes. But process same. So I'm looking at these guys. I've got the cube root of 8 here. What is the cube root of 8? 2. Because look, it's in my list. So 8 is a perfect cube. 1, 2. What's the cube root of 64? 1, 2, 3, 4. It's 4. What's the cube root of 512? 8. Right? It's the 8th one on my list. 8 cubed. What about, look at this negative. Oh, negative 6. But let's be careful with this. Now, we talked about square roots. Did we ever have something like the square root of negative 4? Have we seen any negatives under a square root? Why not? You can't. Why can't you? Because what might this be? Are we thinking maybe negative 2? Well, what is negative 2 times negative 2? Oh. Is there any number times itself that's going to give me a negative number? So there is no real number that I can use to express the square root of negative 4. Well, what about the cube root? I'm going to take a little bit easier one, negative 8. Well, does negative 2 work? It didn't work for squaring. But remember what cubing is. It's 3 times, right? So what's negative 2 times negative 2? Positive 4. What's positive 4 times negative 2? Oh. So it works with cubing. So you can actually have negatives as a radicand when you're doing cube roots. You can't with square roots, but you can with cube roots. And it just means you have a negative root. That's all that means. Okay, now let's look at these guys. Now perfect cube factor? 8. So this is, again, same process, but I'm working with a different number list. So 16 is still 8 times 2. Why did I pick 8? Because 8 is a perfect cube. It's in my list. So when I break this apart, what's the cube root of 8? 2, right? The second one on my list. Cube root square root 2. Done. Do we see how it's really the same process? Yeah. So if you get square roots, cube roots, you're doing the exact same thing, except your list is now perfect cubes instead of perfect squares. Makes sense? Everybody makes sense? 3 of you. Excellent. Well, let's try another one. Cube root negative 81. Now, I don't see 81 in my list. But are there any perfect cube factors of 81 and of negative 81? Yeah. 27 times 3. And if you're not sure, then you don't know what's 81. And you work down your list, by the time you get to 27, you can see it's 3. So I'm going to break this down into 27 times 3, but I'm going to make it negative 27 times 3 because it's a negative 81. You're going to break that apart. And these little cubes, the little 3's in here are important. If you leave that out, it looks like square roots. So you want to make sure you have the cube. What's the cube root of negative 27? Is it 3? Is 3 times 3 times 3 negative 27? No. Negative 3. And the cube root of 3, because 3 is not a perfect cube, and there's no perfect cube factors other than 1, so I leave it. Let's look at, oh goodness, cube root of 320. Well, I don't see 320 in my list, so it's not a perfect cube, but does it have a perfect cube factor? Does 125 work? Let's check it out. I'm guessing. Well, let's see, 320 divided by 125. No? All right, let's try a different one. How about 64? No? Did we try 2 success? Not gonna work. 30 times, what is it, 320? 320. I typed in the wrong number. Okay, that does work. 64 times 5 is 320. So this becomes the cube root of 64 times what? Yeah. Break them apart. Cube root of 64 is 4 times the cube root of 5. And I can just count, right? Here's 64. 1, 2, 3, 4. The cube root of 64 is 4. You can also use a calculator to take a cube root. So if you want to use a calculator to say, gee, I can't remember what the cube root of 64, watch the steps. Because while I have a square root button over here, I don't have a cube root button. So do this with me, right? How do you get to a cube root? If you look along the left column, it's third from the top. And see the math button? If you press that math button, look down the list. Do you see cube root? Yeah. Which one? That's number 4, right? So if you go down to number 4, and then you can type in, gee, what's the cube root of 64? And it will tell you. So the calculator can help you find cube roots if you're not sure. Can you do it? You have to press the math button first. And then don't do the number first. Those are those little calculators from last year. So it can help you. So how are we doing? Cube roots of numbers? Is that a big deal? It's a lot like the cube root, the square roots, only a different number list. How do you do what? I'm so glad you asked about the variables. So the next thing to look at is the variables. So I've got my cube root list here, my perfect cubes. Let's kind of remember this. Now remember square root. What was the square root of x squared? X. What was the square root of x to the 10th? X to the 5th. So you remember what you do with an even number? You take the square root by having that exponent. Now cube root's a little different. Let's think about it. What's the cube root of x to the 3rd power? What times what is x cubed? X. What about x to the 9th? X cubed. What about x to the 33? So how are we getting this? How do you get this, Jay? Yes, you're right. Well, which one here? Positive or negative? We are assuming x's are bigger than 0. Can we do that? Yeah, he's absolutely right. Let's assume positive x's because if x was negative, we have to consider the negative root. He's absolutely to make it a little bit simpler at first. But you're right, absolutely right. How do I get these? Why am I dividing by 3? Well, they're cubes, so I want 3 things together will give me the 33. So, and remember, since we had exponents, right? I'm simply going to divide that number by 3. So a perfect cube variable is divisible by 3. A perfect square variable is divisible by 2. Now, what if they're not divisible by 3? So let's look at the cube root of x to the 7. 7 is not divisible by 3. So a lot like we did with the square roots. Remember we subtracted 1. Why were we subtracting 1 with the square roots? To get the variable. Why did we do that? Why did we do that? So with the squares, we did it to get the biggest perfect square. Now I want the biggest perfect cube less than x to the 7. So let's go subtract 1. X to the 6th. Is that a perfect cube? How do I know if it's a perfect cube? It's the exponent is divisible by 3. So x to the 6th. 6 divisible by 3? Yeah. So now I split them apart. What's the cube root of x to the 6th? X squared. Cube root of x. So that's what this one is. So again, I'm looking for the biggest perfect cube. Now let's try this one. I'm going to put it over here. Cube root x to the 23rd power. 23 not divisible by 3. Not a perfect cube. So what can I do to this? What's the biggest perfect cube? Now if I subtract 1, I get 22. Is that divisible by 3? It's not a perfect cube. What should I do? Keep subtracting. How about 21? Yes. Now remember, under here it has to equal x to the 23rd. Times x squared, because is this the same as x to the 23rd? Do I have 23 factors of x there? Yes. Who's following? I hope we're all listening like 900%. Okay, let's break it apart. And let's see what we get. Cube root of x to the 21st power. X to the 7th. Right, just divide it by 3. Can I do anything with this x squared? No. I can't, there are no perfect cubes in there. There's 2 less than 3. I'm done. So with the cubes, you have to think a little bit more. It wasn't like automatic with the x squared. Just take 1 less. Or you don't even have to understand what you're doing. This one you really have to understand what you're doing. Well, let's try this guy right here. Cube root. Look at, oh, that's hard. Well, is it really that much harder? What do we do first? Separate them, split them apart. So it's the cube root of x to the 17th times the cube root of y squared times the cube root of z to the 21st power. So let's work on the first one. So 17, is that x to the 17th perfect cube? Now, right, that's divisible by 3. Let's see, you have to split it up. If I go 1 less, I get x to the 16th perfect cube. Now, let's go 1 less than that. What do I get? 15, which is a perfect cube. So if I want this to be equivalent to x to the 17, what do I multiply by? X squared. Cube root y squared. We're working on this guy. Can I reduce that at all? This is as simplified as I can get. Because at 2, this is less than 3. It's as simplified as I can get. There's no perfect cubes there. And let's look at this one. Cube root of z to the 21st power. Z to the 7th power. 21 is divisible by 3. That's a perfect cube. All right, we're getting closer. Let's split this guy up. Cube root x to the 15. Whoops. Times cube root x squared. We already said there's nothing we can do with that, so this is kind of a long derive. Z to the 7th is already reducing out. Cube root x to the 15. What's that going to be? What's that going to be? X to the 5th power. What's a 15? Cube root x to the, did I do anything? Cube root x squared. Cube root y squared. Can't do anything. So I've reduced as much as I can. What's my final step with this? What do I do with it?
Put the things outside of the in the front and the side.
Yes. Stuff I've taken outside the radical we put up front, and stuff that's inside we stuff back in one radical. So look at that. That's that one. Wow. It looks hard. Is this very, very different from what we were doing with the square roots? We're dividing by 3 now instead of dividing by 2. And we're looking for perfect cube factors. Let's try this guy. I'm just going to move this stuff. And let's try the other one that we've got in this row. So split them apart, right? 54 cube root x to the 12 cube root y to the 10 cube root z to the 3rd power. Okay, now I've got a number. I have to see, it's not a perfect cube, I don't see it in my list. Is there a perfect cube factor hiding there? 54. We can use our calculator to help. So 54, well, it's not going to be, well, it could be 27. Let's see. Oh, 54 is 27 times 2. So I do have a perfect cube factor. 27 times 2. How about the cube root of x to the 12th power? What is it? X to the 4, right? It's divisible by 3. It's a perfect cube. Notice, not under the radical anymore. Once you find the root, it's out of jail. What about y to the 10? Oh, no.
Y to the 9 times x.
So was it enough to just subtract 1? How come in this case I only have to subtract 1 from the 10? 9 is divisible by 3. 9 is a perfect cube. How about the cube root of z to the 3rd power? What is that? Z. Isn't z times z times z to the 3rd power? And look, outside the radical, you've taken the root. Take it out. You need to make a little arrow to remind yourself it's outside the radical. Do it. So now I've got the cube root of 27 times the cube root of 2. Now this next to 4 is out. So he's out. Oops. Cube root of y to the 9, cube root of y, split those apart, and z is out. No radical there. Alrighty. Cube root of 3 to the cube root of 27 is 3. Cube root of 2. Can I do anything with that? It's already simplest form. The x to the 4th was out. What's the cube root of y to the 9th power? 9 divided by 2, y to the 3rd power. Nothing I can do with the cube root of y. And there's z. Almost done. Last step here. What should I do? Oh my goodness, look at this thing. I did. I simplified. But yes, the order. So you put all the stuff that's outside. This. He goes up front. Please put them in alphabetical order. So numbers go first, then alphabetical order with the variables. What's going inside the cube root? I've got a 2 here and a y here. Look at that. Wow. Questions? Is this a lot of stuff? Yeah, look, stand back and look at it. Yeah. It's frightening looking, but if you do it step by step, it should make sense. Who's it making sense for? 4 of you. Okay.
5.
Everybody, 5.
5.
Okay. We all need to get there. All right, I'm going to erase this part. Do we have this written down because I want to do a final row here? We're supposed to write this down?
What?
If I'm writing this on the board, and I told you to take out a piece of paper, do you think it's important? Oh well, because I kind of need room for this one. Let's see if I can duplicate this and I'll do it that way.
Pop over.
Duplicate. Let's see. Okay, well, I'm going to have to erase it. We did something. Okay, yeah, so I'm going to erase it on this one and I'll show you the rest of it. Let me just get rid of the annotations. Okay, let's try this row right here. Because now we're talking about the fractions and rationalizing denominators. So just a little bit higher, cube root of 27x3 over y to the 9th. What's my first step? Can I have a fraction inside a radical? Before I even do that, Terry, there's one more step I want you to practice doing. Separate them. Separate them. Well, this is what I was going for. I want you to separate them into 2 radicals. And then we can do exactly what you were saying. Because now I can focus on this one, and then I can focus on that one. So he's right. The cube root of 27. Yeah. So I can take that one out, because that's in my list. What about the cube root of x to the third power? Yeah, it's x. Because x times x times x gives me x to the third power. What about the bottom? Cube root of y to the ninth? Yeah, it's a perfect cube. It's y third times y third times y third. Yes, ma'am. How do you get the 3? How do I get what 3? Oh, because look, here it is in my list. 1, 2, 3. Yeah, so you gotta keep that list really handy until we get more used to what the cubes are. All right, let's try this one now. Okay, so now I've got this. One of my rules of simplification is that I cannot have a radical in the denominator. Cannot have a radical in the denominator. So I need to rationalize it. Now this is where we kind of keep our brains really turned on. It was kind of autopilot. Remember for square roots? If it was a square root, you just multiply by that same thing, because the square root of x times the square root of x was x, and then whatever you get on top, right? Say right.
Right.
Good. All right, now this one, you got to think a little bit more. We're going to think a little bit more here. Because I don't want to just multiply by the cube root of x squared, because it gives me the cube root of x to the fourth. It's not helpful. I want a perfect cube after I'm done multiplying. I'm almost there. I've got 2 x's. What would make it a perfect cube? How many more x's do I need? 1 more x. So if I multiply by this, x squared times x, right? What's that? X cubed. So I'll have this in the denominator, right? And what is the cube root of x cubed? X. So this will get me there. My goal is to get rid of the radical in the denominator, multiply by this. So in the top, I get the cube root of x over the cube root of x cubed. Well, that's the cube root of x over x. Not for should be a little closer. Yeah, so it's slightly different. We really got to think about how do I get a perfect cube in the denominator so I can release that. Let's try this last one, which is a kind of a complicated one. So let's see if I can make a little room for it. Complicated. I mean, these weren't the complicated ones. I'm going to split them apart, right? Isn't that my first step? Split them into 2 radicals. Cube root of 24 over the cube root of x to the 10th. So let's work on them separately. The cube root of 24. Now I don't see 24 in my list, but are there any cube root factors of 24? 8, right? So this is the same as the cube root of 8 times 3. What about the bottom now? It's not a perfect cube, not divisible by 3. So what's the biggest perfect cube then? X to the 9th, and then times the x. Let's split these guys apart. And let's see what we get. What's the cube root of 8? 2. Cube root of 3, that's as low as I can go. What's the cube root of x to the 9th? X to the 3rd power, and nothing I can do with that cube root of x. Okay, so I simplified it as much as I can, but I still have a radical in the denominator. How am I going to clear that thing out? I'll put that out of there. What would I multiply by? That gives me the cube root of x squared. Is that enough? Is cube root of x squared, is that a perfect square?
No.
I think I need another x, right? Because x times x squared gives me an x cubed. That'll do it. Whatever I do to the denominator, do up to the numerator. Oh no. Let's look at the top. 2 times the cube root of what? 3 times x squared. Over, now this x cubed is still here. Cube root of x3, which I can reduce. 2 times the cube root of 3x squared over x cubed times x, right? 2 times cube root of 3x squared Oh my goodness gracious. Well, that was kind of a lot of steps. It's about as hard as I'm going to give you, I think. But could we follow it? Do we see where we're, no, tell me where. You got to stop me when it's no. Yes. Where? Yeah. This part?
Yeah.
Now remember, I need a perfect cube before I can take it out. Don't I? So if I just multiply by x, I'm going to get this. Is that a perfect cube? No. So if I, no, because that's not divisible by 3. Has to be, the exponent has to be divisible by 3 to be a perfect cube. 2 is not. So I'm doing x squared. What's x times x squared? X times x squared is x cubed. Is that a perfect cube? So I'm looking for perfect cubes. Yes.
Are these kind of questions going to be on?
Sure, everything is fair game. I hope we're listening. If you get
And this is going to be on.
these are not the kind of questions you want to be asking now. You want to be saying, well, gee, how do I do this? It can be. It is fair game. So make sure you understand this. Ask the question. Yes.
So this, like the cube root, I get another
Yes. They're the same. There's a little bit of tricky with this. I want a question about this.
on your head right
On
now.
your head.
On my head.
Oh.
Never do that.
All right, let's look at this again. So I can't. Is this a perfect cube? How do I know if it's a perfect cube or not? Right. 7 divided by 3, not a whole number. So I want it to be something that will give me a perfect square. So what would I multiply by? X 7 times 1x, is that enough? Because what will that give me? X to the 8th. What should I multiply by? What if I do x squared? X to the 7 times x squared, how many factors of x? 9. Is 9 divisible by 3? So won't that work?
Yes.
So if I do it to the bottom, you got to do it to the numerator. What is 1 times cube root of x squared? Okay, what is the cube root of x to the 7 times the cube root of x squared? Well, what is the cube root of x to the 9? Now, I've gotten rid of the radical in the denominator, which is my goal. Yes?
There was like a 7 before, but then how do you get to a 2?
I'm multiplying. I'm multiplying by 1. Same thing over same thing. I'm multiplying by 1. You see how these match? Amber. These are the same expression, aren't they? As long as x isn't 0, what is this over this equal? Same thing. I'm multiplying by 1. Does multiplying by 1 change the value?
No.
What's 2 times 1? 2. So multiplying by 1, it's going to look different, but it's really the same value. Why did I choose this? Because multiplying x to the 7 times x squared gives me x to the 9th, which is a perfect cube, so I can take it outside the radical. Yes?
How did you get from x cubed x squared to x cubed to 9?
I'm multiplying. That's the same as the cube root of these two things. This times this. See the signs? It's a fraction.
How is that?
7 factors of x times 2 more factors of x. How many factors of x? How many factors of x do I have? That's where it came from.
Oh.
Remember all that time we spent on those exponents? Yeah, that's why it matters. Could we follow through?
Yes, why
No. What happened to the top?
You multiply the top.
I did. Because this has to be a 1. Whatever you multiply the denominator by, you have to multiply the numerator by, right?
So then we add them.
1 times cube root of x squared. What's 1 times the cube root of x squared? The cube root of x squared. And that stayed. That didn't change. And then the bottom, I just took the square root. Cube root. Can I simplify this?
Oh, no,
she sure did. Yes, she did. She just followed it through. I didn't ask a question. I didn't follow through. Where'd you get lost?
Yes.
That's not going to help you, is it? Where did we get lost? I'll do an easier one. Can I have a cube root in the bottom? No. Is this a perfect square? No. What would make this become a perfect square kind of exponent? So what should I multiply it by? If I multiply the bottom by the cube root of x, what should I multiply the top by?
Cube root of x.
What is 1 times the cube root of x? What is the cube root of x to the 14th times the cube root of x? Cube root of what? And what is the cube root of x to the 15th?